All right, let's talk about one of the most important things in programming, making decisions. Today, we're cracking the code on Java selections. You know, the if, else, and switch statements that are pretty much guaranteed to pop up on your next exam. By the time we're done here, you're going to understand exactly how to make your code smart enough to handle just about anything. So, let's get right into it.
So let's kick things off with a super common scenario. Your program's job is to calculate the area of a circle. Sounds easy enough, right? But what happens if a user types in a negative number for the radius? All of a sudden, our simple little program has a big problem. How are we supposed to deal with that? Right now, without any smarts built in, the program would just go ahead and try to do the math, which would spit out a totally useless, nonsensical answer. This is a classic issue we call input validation, basically making sure the data you're getting is actually usable. Our code needs to be tough enough to see bad data and say, nope, not going to use that. And that right there is exactly what selection statements were made for.
So here is our roadmap for today. We're going to start with the absolute core question, true or false. Then we'll build on that with the simple if statement, expand it out to if else, learn how to handle lots of different options with switch, and then we'll wrap up with a really cool pro shortcut called the conditional operator. Let's do it. Okay, first things first, let's get down to the absolute foundation of all of this. Before a program can make any choice at all, it has to be able to answer a simple yes or no question. Seriously, every single decision, no matter how complex it seems, always boils down to a single true or false. And in the world of Java, that true or false value gets stored in a special kind of data type called a Boolean. It can only ever be one of those two things, true or false. Just think of it like a light switch for your code's logic. Is it on or is it off? Every decision we're about to build starts by checking the state of one of these little Boolean switches. So how do we get those true or false values in the first place? Well, we use these 6 relational operators to compare things. You've got your standards, of course, like greater than and less than. But listen up, because for your exams, you have to pay close attention to the last two. The double equal sign, double equals, is for checking if two things are equal. I can't stress this enough. A single equal sign is for assigning a value, not comparing. That's a classic exam trap. And then, the one with the exclamation point equals, checks if two things are not equal. These operators are your toolkit for asking the questions that your code needs answers to. Okay, so we know how to ask a question. Now let's use our first tool to do something with the answer. We're going to start with the most fundamental decision-making structure there is, the one-way if statement. This is how you tell your program, hey, run this specific chunk of code, but only if this one condition is true. This flowchart here just shows the logic perfectly, doesn't it? The program is just chugging along until it hits that diamond. That's our if condition. If the answer to the question is true, the code follows the path into that block of code. But if it's false, it just skips right over it and keeps on going. It's literally a one-way gate. So now we can go back to our circle problem and start to fix it. By wrapping our area calculation inside an if statement that checks if the radius is greater than or equal to 0, we've basically hired a security guard for that line of code. The math only runs if the input is valid. And just like that, we've solved half of our problem. But wait, what happens when the radius is negative? Right now, our program just does nothing. It skips the calculation and moves on. What if we want to actually do something in that situation? Like, I don't know, print an error message. For that, we need an alternative path, and that is exactly what the if-else statement is for. You can see it perfectly here. The if-else creates a clear fork in the road. The program gets to this point, and it has to go down one of two paths. It can't go down both, and it can't skip them. If the condition is true, boom, it runs the if block. If it's false, boom, it runs the else block. One of them is guaranteed to execute, which is a really key difference from the simple if we just saw. And there we have it. With that, our negative radius problem is completely solved. Check out the code. If the radius is valid, we calculate the area. Else, meaning in every other possible case, we print an error about negative input. Our program is now what we call robust because it can intelligently handle both outcomes. Okay, time for another classic exam-style problem. We've got a chain of if-else if statements that are supposed to assign a letter grade. So if the score is exactly 70, which letter grade gets printed out? Let's walk through the logic step by step exactly like you would on a test. So the computer always starts at the very top. It asks the first question. Is 70 greater than or equal to 90? No, that's false.
So it completely ignores the code for grade A and immediately drops down to check the very next condition in the chain. Okay, so the next check it hits is else if score greater than or equal to 80.0. Is 70 greater than or equal to 80? Nope, still false, so it keeps going and lands on the check you see here. Else if score greater than or equal to 70.0. Okay, is 70 greater than or equal to 70? Yes, that's true. So it dives into this block, print C. And here is the absolute crucial part for any exam. The moment it finds a true condition, the entire if-else-if chain is finished. It's done. It completely skips checking for D or F. It just exits. That's why the order of these checks is so incredibly important. Now, these chained if-else statements are super powerful, but, when you find yourself checking one variable against a whole list of specific exact values, there's often a much cleaner tool for the job. And that tool is the switch statement. If you want to absolutely ace any question on switch statements, you need to burn these 4 rules into your brain. First, the thing you're switching on has to be a simple type, like an integer or a character. Second, your case values have to be constants, fixed values, not other variables. Third, you can have an optional default case, which is kind of like your safety net. It's the final else. And fourth, and this is the big one, the break keyword. Understanding what happens when you forget to put that in is the secret to almost every tricky switch question they could throw at you. And here's a perfect example of one of those trick questions. Let's say we have an integer called day, and its value is 2. What is this piece of code going to print? Now look very, very closely. See what's missing after case 1, case 2, case 3, and case 4? There are no break statements anywhere.
Okay, so the program looks at the value of day, which is 2. It scans down the list and correctly jumps to the line that says case 2. So far, so good. That's its entry point. But the story doesn't end there.
And here it is. This is the trap. Because there's no break statement in case 2, the code does not stop. It falls through to case 3. Still no break, so it falls through to case 4. Still no break. It keeps falling until it gets into case 5. Finally, in case 5, it finds something to do. It prints weekday. Then, it finally hits a break statement, and only then does it leave the switch. This fall-through behavior is such a critical concept for any exam. You gotta know it. So the main takeaway here is really simple. That break keyword is what keeps each case separate. Without it, you get that weird fall-through behavior. Now, 99% of the time, you're going to want a break in every single case to avoid bugs. But knowing that you can intentionally leave it out to combine cases, well, that's an advanced trick. All right, for our last topic, let's look at a really clean, really compact shortcut. For those simple situations where all you're doing is choosing between 2 values based on some condition, you can use something called the conditional operator, or as a lot of people call it, the ternary operator. Check this out. On the left, you've got your standard if-else block. It works perfectly fine, but it takes up 5 whole lines. Now look at the right. That's the exact same logic, but using the ternary operator. Let's break it down real quick. First, you have the Boolean condition in parentheses, then a question mark. Right after the question mark is the value you use if the condition is true. Then you have a colon, and right after the colon is the value you use if the condition is false. It is a full if-else statement packed into one super clean, super concise line of code. Okay, to bring this all home, here's one final exam-style thought problem for you. Let's go back to that greeting scenario, assigning an A, B, or C based on numeric ranges, like 90 and up or between 80 and 89. Which tool is the better fit for that job? A chained if-else statement or a switch? Now, think back to the rules for a switch statement we just covered. The answer to why you'd pick one over the other, well, that's the difference between just memorizing syntax and truly understanding how to write great code. Master that why, and you'll be more than ready for your next test.